determine the complex exponential Fourier series coefficient of the figure shown below and determine Fourier series coefficients from complex exponential Fourier series coefficient. The waveform is here shown in figure. X of t this one is one is 1 minus 1. Here 0. Here T naught by 2. Here T naught minus T naught by 2 minus T naught. Here assume T naught is equal to 2. T naught by 2 is 1. Here T naught is equal to, the value here is 2. Here minus 1 and minus 2. Determine expressions in the interval 0 less than or equal to t less than or equal to 1, 1 less than or equal to t less than or equal to 2. Here 0 comma 0. Here 1 comma 1. Here 1 comma 0. Here to here 2 comma minus 1. From this point to this point is 2. Here this point to this point is minus 1. 2 comma minus 1. Here this point to this point is 1. T naught by 2 is 1. And there is no y axis value, that is 0. Here 1 comma 1. From this point to this point 1. But that is 1. Now calculate these values. Consider 0 comma 0 and 1 comma 1. This one is x1 y1, x2 y2 in the interval 0 less than or equal to t less than or equal to 1. And one more equation is 1 comma 0, 2 comma minus 1, x1 y1, x2 y2, 1 less than or equal to t less than or equal to 2. Y minus y1, y2 minus y1 by x2 minus x1 into x minus x1. Y minus y1 is 0, y2 is 1 minus y1 is 0, x2 is 1 minus x1 is 0, x minus 0. That is y is equal to x. Y is x of t, x is t axis. And coming to this one, y minus y0, y1 is 0, y2 minus y1 is minus 1 minus 0, x2 2 minus x1 is 1, x minus 1. That is y is equal to x minus 1, that is 1 minus x. Y is nothing but x of t, 1 minus t in the interval 1 less than or equal to t less than or equal to 2. Now calculate Fourier series expansion coefficient. CN, complex exponential Fourier series coefficient 1 by t naught plus capital T x of t e power minus j n omega naught t dt. Here from this one, here t naught here, this value is t naught plus t. T naught is equal to 0. T naught plus t is equal to 2. Therefore, t is equal to 2. T is equal to 2. That is equal to 1 by 2. T is 2. T naught is 0. 0 plus 2 is 0 to 0 to 2 x of t e power minus j n. Here omega is 2 pi by t small t dt. That is equal to 1 by 2 0 to t 0 to 2 x of t e power minus j n. 2 pi by t is 2 to cancel t dt. Split 0 to 2 is split into two intervals 0 to 1 x of t e power minus j n pi t dt plus 1 to 2 x of t e power minus j n pi t dt. Here 1 to 2, 1 by 2. Here 1 by 2. Integral 0 to 1 is x of t is t e power minus j n pi t dt plus integral 1 to 2 x of t is 1 minus t already determined. These values are already determined. 1 minus t and t 1 minus t e power minus j n pi t dt. Simplify this one. That is equal to 1 by 2 t first function t into integral of second function e power minus j n pi t by minus j n pi minus derivative of first function dt by dt, that is derivative of this function dt by dt is 1. Again integration of this entire function, that is e power minus j n pi t by minus j n pi minus j n pi in the interval 0 to 1. Coming to this one, 1 minus t. First function is 1 minus t. First function is 1 minus t. Integral of this one e power minus j n pi t by minus j n pi minus derivative of 1 minus t is constant derivative is 0 minus dt by dt, that is minus 1. Again integral of this entire function e power minus j n pi t by minus j n pi minus j n pi that is 2 to 1 entire closed, that is equal to 1 by 2. 1 is substituted here. T is equal to 1. Minus sign is there. E power minus j n pi. T is 1 upper limit minus j n pi. Here minus into minus. This is plus j into j square minus 1 minus into minus plus. That is plus. Here 1 is substituted here. E power minus j n pi. N pi into n pi. N square pi square. Therefore upper limit is okay. Next lower limit. Here 0. T is equal to 0. 0 into something is 0. Here minus 1 by n square pi square. 1 by n square pi square. Because j into j square already minus 1, minus into minus plus. That is the reason only n pi is there. N pi into n pi, n square pi square. For lower limit we use minus sign here. And substitute 2 here. 1 minus 2, minus 1 minus into minus plus. E power minus j n pi 2 by j n pi. Here minus into minus plus j into j square minus 1 minus cancel. Therefore here minus sign is there. Minus e power minus j 2 n pi by n square pi square. That is the upper limit. For 1 is substituted. 1 minus 1 is 0. Here minus into minus plus e power minus j n pi by n square pi square. Here Cn is equal to e 1 by 2 is multiplied here. E power minus j 2n pi by 2j n pi. And here minus sign minus e power minus j n pi 2j n pi. Here e power minus j n pi n square pi square plus e power minus j n pi n square pi square. 2 by 2 1. These two are considered. Plus e power minus j n pi n square pi square. Here 1 by 2 is there. 2. This one is completed. Here this one is completed. This one is completed. The remaining term is 1 by n square pi square 2n square pi square and minus e power minus j 2n pi by n square pi square. This is the Cn. Now calculate C minus n. C minus n value is here 1 by 2. Here 1 by 2 is also there. Here 1 by 2. Cn is equal to e power minus j 2n pi by 2j n pi minus e power minus j n pi by 2j n pi. Here minus 1 here e power minus j n pi by n square pi square minus 2n square by pi square minus e power j 2n pi by 2n square pi square. This is the Cn. Now C minus n. To calculate C minus n, that is C minus n is equal to n is replaced with minus n. N is replaced with minus n. That is here n is replaced with minus n. Minus into minus plus e power j 2n pi. Here minus is there. 2j n pi. Here minus n. Here minus n. That is equal to minus into minus plus e power j n pi 2j n pi. Here e power minus j n pi, n is replaced with minus n, that is equal to e power j n pi by n square pi square, n square pi square. Here n is replaced with minus n, therefore the value is as it is, minus 1 by 2n square pi square minus e power minus n e power j 2n pi by 2n square pi square. This is the C minus n. Now coming to, we have to calculate Cn minus C minus n. Now we have to calculate Cn minus C minus n. Here e power j 2n pi by 2j n pi. This is minus e power minus j 2n pi by 2j n pi minus into minus plus e power j 2n pi by 2j n pi. And here minus e power minus j n pi by 2j n pi. Here minus sign is there. Minus sign is common here, plus e power j n pi by 2j n pi. Here plus e power minus j n pi by n square minus pi square minus e power j n pi by n square minus pi square. Here e power, here minus 1 by 2n square pi square minus and minus plus, these two are cancelled. These two are cancelled, and one more term is there, that is e power minus j n pi by 2j. These two, this one and this one and this one is completed. These two are cancelled. These two are cancelled, and one more term is there, that is n square pi square e power minus j n pi n square pi square. Here minus e power j n pi by n square pi square, and here minus e power minus j 2n pi by n square pi square plus e power j 2n pi by 2n square pi square. This is the entire. Okay, now that is equal to 1 by j n pi 1 by j n pi e power minus e power j 2n pi plus e power minus j 2n pi by 2 is, write it down as e power j 2n pi plus e power minus j 2n pi by 2 minus 1 by jn pi e power jn pi plus e power minus j n pi by 2. Here 1 by n square pi square e power minus j n pi means cos n pi minus j sin n pi. Here minus cos n pi plus into minus j sin n pi. Minus this one is 0, sin n pi is 0, sin n pi is 0. That is cos n pi plus cos n pi minus cos n pi. That is the entire term is 0. This one is 0. And coming to this one, 1 by 2n square pi square, 1 by 2n square pi square e power cos 2n pi minus j sin 2n pi plus 1 by 2n square pi square cos 2n pi plus j sin 2n pi. J sin 2 pi n pi is 0, j sin 2 n pi is 0, minus 1 by 2n square pi square cos 2 n pi. Cos 2 n pi is 1, minus 1 by 2n square pi square plus 1 by 2n square pi square. These two are cancelled, that is 0. Finally, Cn minus C minus n is equal to 1 by j n pi cos 2n pi minus 1 by j n pi cos n pi. That is, we know that Cn is equal to An minus jbn by 2. C minus n is equal to An plus jbn by 2. 2Cn is equal to An minus jbn. 2C minus n is equal to An plus jbn. Subtract these two. 2 into Cn minus C minus n minus 2j bn. Numerator and denominator is multiplied with the j into j square. J square means j into j square. J square is minus 1, minus into minus plus 2 to cancel. Therefore, finally, bn is equal to j into Cn minus C minus n. Cn minus C minus n is equal to 1 by j n pi cos 2 n pi minus cos n pi. 1 by j n pi cos 2 n pi minus cos n pi. This is j cancel. Finally, bn is equal to 1 by n pi cos 2 n pi minus cos n pi. This is the bn. Now calculate Cn plus C minus n. Cn plus C minus n. We know that Cn is equal to, again in that expression, Cn is equal to e power minus a 2n pi by 2j n pi minus e power minus a n pi by 2j n pi minus 1 by 2n square pi square plus e power minus a n pi by n square pi square minus e power minus a 2n pi by 2n square pi square. C again, C minus n is equal to e power minus a 2n pi. Here n is replaced with minus 1, that is present plus n. Here n is replaced with minus n, that is minus 2j n pi. Here n is replaced with minus n, minus into minus plus e power j n pi by 2j n pi. Here 1 by, as it is, because n is replaced with minus n square is minus n whole square is n square, 2n square pi square. Here n is replaced with minus n, e power j n pi by n square pi square minus e power, here n is replaced with minus n, 2n pi by 2n square pi square. Cn plus C minus n is equal to here e power minus j 2n pi by 2j n pi minus e power plus j 2n pi by, here write down here e power minus j 2n pi by 2j n pi minus e power plus j 2n pi by 2j n pi. Here minus e power minus j n pi by 2j n pi. Here minus 1 by 2n square pi square minus 2n square pi square, that is 1 by 2 is common, 1 by 2 plus 1 by 2 is 1, that is 1 by n square pi square. Here e power minus j n pi by n square pi square plus e power j n pi by n square pi square plus e power j n pi by n square pi square plus e power minus j n pi by n square pi square. Here minus e power minus j 2n pi, this one, by 2n square pi square. Here minus e power j 2n pi by n square pi square. that is equal to here minus sign here, e power j 2n pi minus e power minus j 2n pi by 2j 1 by n pi is common term. Here minus sign is also there, here minus. One by n pi. Here also plus e power j n pi minus e power minus j n pi by 2j 1 by n pi. 1 by n pi. Here minus 1 by n square pi square. Here multiplied with 2 by n square pi square e power j n pi plus e power minus j n pi by 2. Here minus sign 1 by n square pi square e power j 2n pi plus e power minus j 2n pi by 2. That is equal to finally 1 by n pi sin 2n pi plus 1 by n pi sin n pi minus 1 by n square pi square plus 2 by n square pi square cos n pi minus 1 by n square pi square cos 2n pi. Finally, these two are zeros. Sin 2n pi 0, sin n pi 0. Need not consider. Finally, 2 by n square pi square cos n pi minus 1 by n square pi square cos 2n pi minus 1 by n square pi square. This is Cn plus C minus n. 1 by n square pi square is the common term. 2 cos n pi is minus 1 whole power n. Cos minus 1 whole power 2n minus 1. This is a Cn plus C minus n. We know that 2 Cn is equal to an minus jbn. 2 Cn is equal to an plus jbn. C minus n. Add these two. 2 into Cn plus C minus n. These two are cancelled. Addition 2an. Therefore, an is equal to Cn plus C minus n. That is equal to 1 by n square pi square minus 1 whole power n minus 1 into whole power 2n minus 1. Therefore, an and the bn is determined. Next, find out C naught. C naught is nothing but a naught. Cn is equal to 1 by 2 integral of 0 to 1 t into e power minus a n omega t plus 1 to 2 1 minus t e power minus a n omega t. Here dt is also the dt. But n equal to 0 means c equal to 0, 1 by 2. E power 0 is 1, 0 to 1 t dt, 1 to 2, 1 minus t dt. That is equal to 1 by 2 t square by 2, 0 to 1. Integral of 1 dt is t minus t square by 2, 1 to. T is equal to 1 by 2 plus 2 minus 1, 1. Here minus 4, 2 square, 4 by 2 minus 1 by 2. That is equal to, the value is here 1 by 2. This one is 3 by 2 minus 2 2s are 2. 4 minus 1, that is 4 minus 1, that is 3 by 2. 3 by 2, 3 by 2 is cancelled. Therefore, C naught is 0. C naught is equal to 0 means A naught is also 0. Therefore, AN is determined. AN is also determined. BN is also determined. And the C naught is equal to A naught is equal to 0. C naught and the A naught equal to 0. These values are determined. C naught is equal to 0. A naught is equal to 0. The value of AN is equal to 2 into minus 1 whole power n minus 1 whole power 2n minus 1 by pi square n square. Bn is equal to minus 1 whole power 2n n pi. These two values are already determined here. N square pi square 2 into minus 1 whole power n minus 1 whole power 2n minus 1 by n square pi square. These are the values are determined. Finally, x of t is equal to a naught sigma n is equal to 1 to infinity an cos n omega t sigma n is equal to 1 to infinity bn sin n omega t. A naught is 0. Sigma n is equal to 1 to infinity. An is 2 into minus 1 whole power n minus 1 whole power 2n minus 1 by pi square n square cos n omega is 2 pi by 2. 2 pi by t is 2 plus sigma n is equal to 1 to infinity. Bn is minus 1 whole power 2n minus of minus 1 n by n pi sin n omega is 2 pi by 2. The 2 to cancel. This is the final total Fourier series expansion of that periodic signal. This is equal to 1 by n pi cos 2n pi is minus 1 whole power 2n minus 1 whole power n. With this, total derivation is completed. If you like this video, please subscribe the channel for further updates. Thank you.